learn and understand and adapt my approach to development. And ultimately, the fact that a couple of them blew up and are getting millions of downloads a week at this point, is that like you throw enough spaghetti at the wall, some of it sticks, which is probably the answer. And then I followed the ones that stuck, and it just so happened the ones that stuck were, funny enough, the things I was particularly interested in, like Flow or Claude Flow, right? As a kind of agentic management system. As an agentic engineer, having a popular agentic platform isn't the worst thing in the world for me. And the RuView thing ended up being a nice sort of ancillary component for all the stuff I'm doing with Cognitum, which involves signals and real world AI, and it just so happens to be the most popular platform for spatial intelligence at the moment. So, is it by luck? Is it because I was first? Is it because I did enough that some of it stuck? And what's the expectation of a sole developer to support the that many projects? I'm right now comfortably supporting, including my customers, my various open source projects that I care about, probably around 30 different projects right now today, and that includes this Vibecast. Am I doing a good job of it? Well, I'm doing a better job now that I have you guys help me, but probably not.
It's a high
Ruben,
class problem to have,
actually,
right?
I mean, can I ask you a question, Ruben? And this is probably similar to other people around or on this call. How do you manage when you switch from one project to the other? You must have a cold start in cranking up, getting back into that project. How do you manage that side of things?
I've got a federation. Well, I've got a brain, so I've got a number of things. You're right. The cognitive limitation is me and my ability to, and keep in mind I have an unusual ability to retain information. As if you guys have ever tuned into these Vibecasts, you realize I remember a lot of stuff that is interesting to me. If my wife tells me to go pick up the eggs on the way home, I'll forget. But when it comes to like, computer science and emerging technologies, I have the ability to retain a lot of that. And that's very helpful in a kind of approach that I have where I'm jumping across multiple projects at any given point. Now, there's a kind of maximum that I can kind of retain even within that. And to offset that, I've created a kind of augmented brain structure, which I call my MCP brain or whatever. And that allows me to have the system understand business things that are proprietary in nature related to a project or things that I'm working on that I don't share publicly. And then there's secondary brains like the Pi brain that ingests a lot of the work that I'm doing around RuVector and other open source projects. So the system becomes bounded and more, maybe the word's grounded in the data and information that relates to that. So when I hop on to one of my various VS Code instances, which are essentially right now running on either my Linux box, my Mac Mini Studio, or a series of cloud-based environments that I do for different projects. It allows me to get it back up and speed quickly. The other thing I do is I've got a federation component. And if you see that at rootflow/federation, that allows my agents to communicate with each other within the private network of my Tailscale. So Agent A can communicate with Agent B on a completely different computer, but through a shared sort of network topology. I don't know if
Mm.
that's answers your
That would,
question or.
yeah, well, that is probably one of the more valuable keys because, I've been experiencing this cognitive problems recently. Like I had, 7 branches of a project being run by Claude independently. And, I get to the point where I think, what the hell is already implemented? What is supposed to be implemented? And I thought this was implemented, but it's not. And why? And, you begin to implode at that point.
When
Well,
I
the
first
ADRs.
started using this technology, I created something called Prodigy to help me context switch between projects. So it would switch me to the right terminal and the right code, visual code session, because the context switching when you have 20 things open is crazy, right? You can't even find it on your desktop. So I think tooling to allow people to switch between tasks effectively is a big deal.
Mm.
Well,
It
you should
is.
see my desktop. I've got this 50-inch screen. I've got the snap in place. So my 50-inch has 3 VS codes, and I've got my laptop, which is a double screen laptop. So just in front of me alone, I've got one, two, three, four, five, 6 screens plus another, two screens over here, another two laptops. So my office is just buzzing with sensory input. But the cognitive offload, the ability to actually understand what's happening at any given point. I'm the orchestrator, and I feel like I'm like in front of an orchestra a little bit, and I'm kind of, moving my arms around and clicking here and there to keep things aligned. And I've got a system that seems to be able to produce quite well based on that.
Well, it's
I'm
one thing
quite.
going from project, going from like a code project to the other, but it's also when you're in a, when I find I go from one meeting to another, I got a meeting in 2 minutes. What was we talking about last? And it's to-do lists, all of these things don't work anymore because there's too many. It's not like 5 things you're working on, it's 30.
Or more than 30. Sometimes 30 is a normal day. Yeah.
I
And
quite like the ADR approach. I think that goes very well for every project. You have a canonical source that you can keep track of. I do that like nowadays before I push any codes is to do a bunch of ADR.
Yeah,
yeah,
but
but
that only addresses the software side of things. But when you're trying to remember what the bigger picture is, and you've got 30 of those, like Roof has, then the ADRs probably don't handle that.
I have a not graph-based system to handle most of those. Like I guess it's about retrieval of those contexts when you need it. Like it is not that possible for me to put all of those in my head, especially like you said, to keep track of what is still stub. So I think the ADR really handles those very well if you plan it to long term. That captures your architectural decisions.
I think
I
having
don't.
a one slide picture of what each project is, and then the here's where you left off last time where you need to continue. That's key for me to jump between projects because I'll be like, I maybe haven't touched the project in 2 months, and I'll go back to it and go, oh, what the hell was I doing here?
Yeah, that
Yeah.
is why the federation thing works, because each project will have their own like project level memory persistence. They can go back into context and retrieve very easily.
The ADRs was a huge win for me as well. Once I implemented ADRs, it gave me the ability to go back and essentially say what was the last ADR I worked on and how does that relate to everything else that came before it. And then to Ocean's point, the ADR naturally creates a kind of hierarchy and mesh or graph structure. This is just the very nature of an ADR. It's an interconnected series of decisions, and it allows the AI to quickly understand all the things that happened and what may still need to be done. And it also avoids the stub issue you have sometimes when you're doing a kind of piecemeal implementation. So, for example, I'm implementing right now a integration for my seed using those Aura rings that you see around that track biometric patterns and whatever. That's been running steadily since last night. And here, if you guys are interested, I can show you what that looks like quickly. Um, so this is Martin, you got to give me sharing. But this is this is what I would consider a long haul or long horizon implementation. So it's been running for now close to 14 hours. There we go.
I'm on
Let's
a,
see.
I'm on the bike. I don't. If you can't do it, then I can't give it to you.
I'm good. I think I got it. All right.
Okay,
So
great.
so so just what's interesting here is if we go up. So you see here what this is what I started 14 hours ago. I said loop 5 minutes, fully implemented, test, validate, secure, benchmark, optimize, and push beyond soda. Now, I like this the push beyond state of the art because it's an ambiguous thing that it needs to do. I have no idea what beyond state of the art really means, but what I do know is the system will keep going until it reaches some crazy implementation that is 100% functional that no one else has ever done before. And that's ultimately what I'm trying to do here. But the key here is you look at these ADRs. So in this case, this is a repo that I sort of forked off in another repo. This is my seed repo. So the original repo was, it was done before the company was incorporated. But you can see here that I've started at ADR 90. So there are obviously ADRs that exist before it, but they were generally speaking unrelated to the particulars of this implementation. And you can see here that last night I started on my Aura Ring implementation. And this is basically, one of my investors is a big Aura fan. He says you should integrate. I'm like, sure, let's do that. So this is the initial ADR, right? So the initial ADR, this is what I looked at when I'm it's like, what am I going to do and how am I going to get that integrated? So there were two parts that I needed to consider. One, there's a cloud API for Aura. But the problem with the cloud APIs means I have to send all my data from my ring to their cloud server, then request it and stream it back. I'm like, well, that's kind of a dumb process because that creates huge latency. And then I still have all my personal information going to Aura, and I got to pay for their $4 a month subscription. It isn't a lot, but why do I need to do that? So then I'm like, well, what if I could just take the direct data from the ring, bypass their service altogether, and use the Bluetooth integration of the ring and use that data. So that's what this is doing, right? So it says, so pull the Aura data from OAuth, which is what I just described, but additionally pair the ring over BLE, Bluetooth low power or whatever. And so that allows me to be a kind of man in the middle of the data. This gives me two benefits. This gives me the benefit of not having to have a subscription. That means I can completely replace the need for having a subscription with Aura, which might not be the best plan if I want to partner with them, but it's certainly a cost-efficient alternative to something that costs $48 a year. And then the next thing I could do is I could then directly pair that with the seeds that I have in place, and that adds another spatial sort of intelligence to my mixture of things that are happening in my environment. My heartbeats are now directly coming off my finger versus being inferred based on CSI. So I get a lot more sort of capability from that. So again, the ADRs you can see are going in a significant amount of detail on how and what it needs to happen. Now, I am the man in the middle here. I looked through this. I made several iterations. This is after me going back and forth with the system for a while. So before I ever got to a 14-hour sort of long horizon implementation, I spent, I don't know how, a couple hours working on this. Then I'm like, okay, what would be interesting is if I not only support Aura, but it turns out I can actually get my own ring manufactured in China or whatever for like a fraction of what it costs for an Aura. An Aura is like $500. I can get my own ring for like $20 or $30. So why not just use that? So I wanted a platform that would be essentially capable of piggybacking on Aura because they've got millions of users, but I also don't necessarily want to use them. That's step two of my implementation plan. And you can see that, and it goes in a bunch of details in that. And these details are a lot less. Oops. And then we're going out into the area of like sort of, I don't know what you want to call it, the more crazy land, ambient psychological inference substrate. I'm like, and I always go down these rabbit holes. This is me at 1 o'clock in the morning thinking, wouldn't that be cool to understand the psychological ramifications? And the reason I came up with this is I'm up at 1 o'clock in the morning, the rest of the family's sleeping, and now I was able to detect that my daughter in the other room was actually going through REM sleep. So I started doing, remote analysis of her and that her REM related sleep patterns over CSI. And that gave me some ideas and so on. And then that led to, okay, maybe I should get some actual sort of kind of differential on the vital signs. Long story short, this has been running since what I guess it's been running since about 10 o'clock last night, Eastern time, so about 14 hours. And it's still going. You can see 491 tests pass. It keeps going through the iterations, and every 5 minutes or so, you'll see that it does a loop. Where's the loop here? Oh, here. So here's iteration 66, and it tells you what it did. Now, if I want to do this publicly, what I would do at each one of the iterations, I would create essentially an issue update. And you can see that on Rooflow for a moment. Let me show you guys that just for a sec. Rooflow, because on Rooflow, I build publicly. So rather than anything being private, I share it directly to the issues. And I did one the other day. Where is it? Here it is, 33. So this is an example of I did a major update to the Roof Vector embedding system in Rooflow. And so this is the first, so I did the ADRs publicly, basically. And we can see that it took 33 turns. So 33 turns would basically have been several hours. Let's say, I think 6 hours maybe. And we see the phases and how it sort of thought through it. Phase one, it did such and such. Phase iteration two, so on and so forth. And it goes and it goes and it goes and it goes. So this is probably the best example you guys can look at if you're looking at kind of long haul horizon development. And using this approach, I'm telling you, there's nothing you can't build. Eventually, it sorts itself out and it'll build whatever crazy you want it to build. I don't know if that's helpful.
Are you using the expensive enterprise models for that, or are you using something
No, no,
cheaper?
I'm not. I'm not using expensive enterprise models for that because it doesn't need it. I don't and I find, especially when you're doing iterative development, the smaller context windows work better because I don't actually want it to remember in this case I've got 66 iterations. I don't need it to remember the first, 40 iterations I did yesterday. All I needed to know is contextually where it is right now. In the smaller context size of the Sonnet 3 or 4.6 model allows it to readjust its memory in context to where it is in the development pattern. So it turns out that the smaller context window actually works better for long horizon than longer ones. Now that isn't always the case. So for example, on the other computer you can't see here, it's actively developing my V0 seed. Now, the reason I want a large context window in that particular environment is because I've got a cluster. And the cluster is made up right now of several Pi 5 with hats, the Halo 10 hats, and it's got 12 seeds attached to it and about a dozen ESP32s. That's a ton of interconnected relationship data. So I want all the data from all those machines to be kept in the context window while it's doing the development of those machines. So in that scenario, I'm actually using the Opus 4.6 1 million context window. But normally I wouldn't do that.
So you're not using local models, you're just using the cheaper Sonnet model or Haiku.
I am using local models. Let me show you how that works.
Quen 3.6 27B, it seems to be the best paired one
No,
right now.
I'm using the 7B. I don't need anything quite so powerful. Is this interesting? I can show you guys if that's interesting. Um,
Which
Let me
model
see
you
what I
say
can.
you're using again?
I'm using the three. I like Gwen. I find it the most flexible for the things I typically do. For I think it's a 3 billion or 2.7 billion parameter model is my go-to for like linguistics. But generally for like quick actions, let me show my screen here. So this is something I'm building as we speak. So this is my onboarding interface, various components or whatever. But once you get past this, you can go to the actual interface. Now, what's interesting for you is under my logic, under agents. So in this scenario, this is what they call a sovereign AI system. When the this is what I call a sovereign AI system anyway. A sovereign AI system is essentially an AI system that sits independently of any network, right? It's self-contained. It can operate in an air-gapped environment. So I don't necessarily have the capability. I could plug in a much higher, bigger GPU, but I don't need it. So in this scenario, I've got the idea of deploying my various agents, so I can go here and do a test. Now I've got other options here that allow me to so I can dispatch. You can see I just dispatch. This is all local, and this particular one is using Haiku. Now if I went to WASM, the WASM would essentially do the same thing, or I could use a tier three, which would be like, your Opus or your Gemini or OpenAI type model. But for most of the things I need in my environment to do, various things like, in this case, pose estimation or room occupancy or neural trading or whatever it is that I have here in the App Store, I don't need those models. Like these applications are so narrowly focused that if I'm going here and choosing retail, for example, in queue length, just as an example, I don't need the model to know everything about everything. I just need it to be able to do the queue length. So in the queue length, all I'm really doing is creating what I call a cog, which is the Rust-based application that kind of sits like a WASM. Two, I've got a vector-based learning and understanding, whatever you want to call root vector system, learns based on a kind of transactional activity, signal, logs, data flowing to and from it. And then last, I've got like a language model that does nothing more than says kind of the most basic, sort of terminology, yes, no, good, bad, outside of norms, like a kind of linguistics of kind of verb-based linguistics that indicates what it needs to do. So I don't need a big giant context window because it's literally 4 words. And I don't need a huge amounts of text because I only really need a sentence. So these tiny models that I optimize specifically for that are all I need. And the last part to do that, I've got, where did I put that? I got a lot of stuff here. I think it was under intelligence. So the intelligence system essentially it's the internal brain. It's how it learns and understands all within its own environment. Again, this is all sitting on essentially a highly optimized Pi 5.
Yeah.
So
Is
again,
Ofer and Antonetta have
is
their hands up as well. Rube, Sena.
oh, sorry, I was just blabbing. Sure, over. How's it going?
All good. I guess semi-related maybe to a previous conversation. Um, Uh, Thank you for being attentive to issues and PRs we're sending. I want to ask, do you have any kind of harness or agents running through to see if certain, like in Rooflow, issues make sense and it already check for you? Like helping you manage an open source project, do you use any of these automation before you actually go into looking into them?
I do every morning, well, not even every morning, but multiple times a day. And I only look at the really popular ones because I get too many repos, as you guys are aware. So I focus on the repos that are essentially trending. That means like they're doing tens of thousands of views a day or whatever or more. And then the benefit to GitHub is, especially with issues and PRs, is GitHub is essentially a direct cyclical data graph structure, right? So it inherently knows the interconnected relationship of previous issues, regressions, bugs, things people hated, things people like. And the more you start using the GitHub system, that just kind of infuses itself into that. And so when you look at like the Roof Flow system as an example again, you'll see that there's, and like if you scroll to the very bottom of these things, here, let me just share the screen quick. You'll see that that just kind of happens. So in this case, here's the very last one that I did before I did the PR. You can see that it sort of integrates, and there's, if you look through, this one's probably not the best because it's original, but you can see it has like related issues. So this would be, this is the same one again, but let's find it. Let's find another one. Let's see what's. I should probably look at closed. Here's a new. Oh, this is someone. I get spam. This is spam. This is not a good one. Here was one from yesterday, opened by someone. So this is a minor bug, but in this case, what I could do is I could just fix it if you guys are interested in seeing me do that. So we'll go. So this is 2086. I've got Roof Flow open here. Hopefully, I don't have any. Let's make sure I don't have any EMVs visible. And this is just, see, I'm just seeing new issues. I'm just review and great. Let's just review and reply. Now I've got different actions I can also take if I want to. So I can go here and I can choose my various additional. I think I've got like I got my different GitHub related ones here. So I got GitHub swarms and review. So I'm going to go with code review or let's just go with this one just to show you. And then I'll say something like review, what did I say, 2086. Oh, I don't need that twice. And so that's going to invoke my skill. And I make my skills just for the way I like to make my things work. And my suggestion for others is customize them if you want to work a certain way. I made it to Thursday on this account. Isn't that's amazing? Usually I run out of this on Tuesday. I guess I'm having a slow week. Or my Sonnet 4.3 3.6, 4.6. I don't know whatever the sonnet number is. Uses less
4.6,
capacity.
4.6, and then they increase 50% of the rate limit until like July or something.
Oh, maybe that's why I'm only at 91%. Yeah, so yeah, so you're literally watching right now me respond to whatever this issue was. Let's see what it is. Root LLM reports available true, but initialize false via LM status, and there's no MCP exposed tool to bootstrap. Okay, so this looks like and see this cross-reference. This is nice. He cross-referenced a previous March 9th fix. So the longer my repo exists, the more cross-references there are. This was 1,000 issues ago. But this is something that was done back then. You can see that I fixed that and I resolved that in a previous, this might be a regression. So if it's a regression, what I have is a CI guard. The CI guard allows me to do really every time I do a fix, the CI guard creates a new well, basically a test that makes sure that that particular type of regression will never happen again. So that avoids that kind of one step forward, two steps back problem you sometimes have with automated development. All right, so according to this, he's right. There is an issue. For there's looks like it might be an issue when related to the MCP itself. So remember, in my environment, there's multiple ways to interact with the application. So in this case, there's a Ruve LLM WASM, which is how I handle the sort of internal language model. I can invoke that directly as an SDK. I can invoke that as an API, and I can invoke that as an MCP tool. And it would appear that the MCP-based implementation has broken. So then we review confirm bug, root cause. There are two distinct entry points, and this is a byproduct of doing multiple things different, doing the same thing multiple ways, kind of problem that I run into sometimes. But it looks like a minor fix. All right. So then I'm gonna say, create a new branch, fix, validate, publish and validate after publishing and update CI guard. That's it. That's all I'm gonna say. And then it'll do it because it's a really simple fix. It shouldn't take more than about 5 minutes.
Is the
You all,
review skill you used something part of Rooflow? It's internal for you, or is it from
Yeah,
somewhere else?
it's part of Rooflow. So there's in Claude, you'll see that there's where did I put that? Commands and GitHub. Yeah, that's how I'm doing it. It's not part of my plugins. Maybe I should. I didn't want to make the plugin skills and it's so crazy that there was a billion things, which I did. There's 32 of them. So I've been a little bit more selective in what gets included in the plugin folder. Where is that in plugins? Yeah, so these are the marketplace plugins. So the GitHub one doesn't exist in that, but I do have a Rooflow Jiu-Jitsu, which does similar stuff.
while
Rue,
that's cooking, Roof, do you want to take Antoinetta's question? She
Sure.
has her.
Yeah, how's it going, Anshana?
Hey everyone, Ruva, I really love what you're doing with the Aura. I'm a big fan of all the sensors, and I have the Aura for 3 years. I have a Whoop, which is more for athletes. I have my watch. I have a mattress on which I sleep, and it generates all kinds of heart metrics and whatnot. But the problem with that is you have four watches, you don't know what time it is. And there's other things. But I think what you're doing is absolutely amazing because there's aspects that these tools don't focus on whatsoever, like all the psychological aspects. They do the physiological piece, but the psychological that you're trying to go after is amazing. And for example, as Eva was developing burnout metrics and whatnot, these are not covered by anybody. At the same time, these tools have some advantages and disadvantages, but what I keep them, like, I pay a lot per month for these things, and the one would wonder, why do you do that? Well, for several reasons. Number one is that they have a huge base of people, right? So although the average is not you, they can actually cook together all this data and actually develop their secret sauce algorithms. So it's a good thing. So we can benchmark our health, right? What does that mean that I slept 6 hours? Is it good? Is it bad? How many people sleep like me, right? But at the same time, our own benchmarking is the most important. And so I think with your tool and constant monitoring, we know our own benchmark and the deviation, and that's the most important and informative thing. And the other thing that I see as a huge benefit to what you're doing is correlating with stuff that I don't want to send on the web, private data, or they're limiting you. You can add 15 things, but the 16 to 75 I can't add whatsoever. But with a tool like what you're developing, it's completely flexible to reflect both psychological ends, my own benchmark, and also correlate with all kinds of other parameters, health parameters that I have, or social for all I want. So I love this, and I think that if many people within this community adopt something like that, then we can have even the referencing with a huge database of people, right? So that we know what's left, right, up, and down on our metrics. Anyway, love what
Well,
you're doing.
Well, everything you just described in terms of the applications and tech that you've got, your smart bed, your smart ring, your smart everything. Basically what I've done, and I'll push the cog out here. Hopefully, well, actually, Dragon's busy today, so maybe tomorrow. But once you've got that, what I'm doing, and I don't know, if hijack is the right word, but I'm hijacking the Bluetooth connectivity of these devices and then saying rather than going to some random cloud provider, I'm basically taking the telemetry from these devices.
Mhm.
So, at the very least, you could cancel your need to subscribe to a bunch of these apps. But now then you can just open up Claude and say, create me a dashboard kind of thing.
Yeah, yeah, totally. I'm with you. I'm still questioning every day, why do I pay for this? And my answer is because they have their secret sauce algorithms that incorporate a lot of data that is actually proprietary to them and the huge database of people. But if we have a community or there is an open database that we can actually cook our own algorithms and benchmark to ourselves, that's all there is.
And keep in mind, I'm also using PII, so I'm doing I can do transfer learning. So hypothetically, let's say we
Mhm.
wanted to take everyone on this call and
Yep.
train a health monitoring system, but we didn't want to necessarily show exactly whose biometric information was coming from whom. So in
Mhm.
that scenario, what we can do is use the trajectories, and then I can share the sort of anonymized versions of the data without exposing specifically who or how or why I got the data.
That would be awesome. I'm up for that experiment if people want to do it. That would be terrific.
I'm
I'd
I'm
like
thinking
to
about
see some
buying.
platforms like Muse, I was
Sorry?
going to say. Sorry. I was just going to say other platforms like Muse, like um, the headband. Those platforms also would be excellent to incorporate.
So I made it abstract. So that cog that showed vital fusion is basically the purpose of that was I wanted to integrate with anything that gave me sort of biometric information, whether that's brain signatures, heart, whatever, without explicitly making it specifically for that application. So it's broad enough that it can take any form of data and understand it without having to be explicitly designed for it. So my Aura Ring one is the opposite. It's explicitly for Aura, and I'm basically using it, for that. So you can kind of, and the reason I was thinking for that is what you just described. I want to go on to Alibaba, buy some crazy, Chinese ring for $20 and see what I can do with it. That's the
That's
most
right.
exciting
And
part.
there are generic headbands too. So totally. I mean, it does completely blow up their business model.
Oh, do we, you guys, am I still coming through or
Yeah.
I
Yep, we can
guess
still
you're
hear
us.
you, Ruth.
Yeah, and I never know if it's I did figure out what my problem was last week with my internet. I have 7 different
In that
Wi-Fi
case, because of a lot.
routers. Nope.
Yeah, we can hear
Martin's
you,
back?
Martin.
Sorry, we lost you for a minute, Martin. You back?
He looks like frozen again.
Okay. Yeah, I don't know. Any comments, Ocean? How you doing, long haul, long horizon? Nope.
Me? Who?
Yeah. I'm just curious how others are doing. Long horizon agents that run for days or whatever.
I use a show approach, which I can share my screen.
Sure, let's see it.
Okay, so share. All right, so this is the front end I'm doing. I'm integrating some of the constructs in the skills into into the front end as well. So this is a place to view everything. And so how I do a very long run will be like this. So this is a show of 6 play. Each play is a whole bunch of agents. Um, not able to see the how many agents here, but I suppose it's about 10 to 15 per play and a couple hours per play, then they just keep on going. Each play is just done by a CLI from the cloud, and then cloud just keep on going. Just after this play finish, check it out. If good, keep on going, etc. It just goes overnight, and then that's typically how I do it. I do not run like for days, that kind of crazy ones, because I use a lot of parallel, and then those are scoped. Those are very scoped. So this one I did with I did initial scan of GitHub issue first, and then I just say run this show, finish it out, and then I go to sleep. And then I woke up, all the issues are resolved. So it's not as like a feature orientated approach. For this, I mainly use this method to clear off small details.
Yeah, I like it. I like the play idea. It's
Oh, and
it
it's a
sounds
DAG based. And it's a DAG based. It can be run in parallel in different work trees. I find that to be very helpful. And each play itself can be multiple work tree by itself, because inside it's a forlorn cloud orchestrator as well. But yeah, this goes to the cloud dash P problem. I don't know how to use this after the dash P because the compute will be so expensive.
use well. When I showed you earlier, remember that agent that I was deploying? I've got a WASM, and so most of the logic it turns out that I need for an agent to do its job, whether it's like code edits, review, understanding, deployment, federation, whatever, doesn't need an LLM. So once I realized that I didn't need an LLM for anything other than like interpretation of the final stage or certain critical sort of thought processes, I could offload something like 80% of that to a local sort of compiled WASM that I could then just point the agent at, and there's an escalation. If it's something like it needs to do deep research or understand something beyond what that WASM's capable of doing, the system's actually capable of saying, I need to escalate to a more capable model or potentially even a person. But the reality was I didn't really need the better model for most of the things I was doing. So as soon as I realized that, I could step away from having an LLM centric agent to more of a whatever you want to call the WASM centric approach.
My take on like very big, powerful cloud Anthropic models are if you're able to do some kind of agentic process with pure Sonnet or Opus, you can do it with any small language model given enough LoRa and fine-tuning.
Yeah, exactly. 100%. That's exactly and the key was the micro LoRa, not just LoRa, but the micro LoRa allowed for an individual weight to be adjusted based on a kind of causal effect. And that causal effect could be if you could get it sublinear, meaning I can make the change faster than the time it takes you to realize that there was something happening, which is basically sub 100 milliseconds. I could make the request, understand the previous requests, understand what this request was related to that request, update the LLM, and then give you the response. And all the things I just described, all happens in like microseconds or single milliseconds. So you don't notice any kind of latency in the request. But a lot is happening before it ever returns a result. In this case, it's basically an incremental fine tuning of the language model itself.
So I've been looking into like a mixture of LoRa adapters. So your approach is more like a real-time tuning of those adapters themselves from the feedback.
Yes, that's exactly what it
Okay.
is. Yeah, it's real-time fine tuning. And the smaller models, it makes it easier to do that. So think of small model. Like I use the 500 million parameter models all the time, and they're tiny. Like I created one of the models I created was 8 kilobytes, and it obviously what are you gonna do with an 8 kilobyte model? But the 8 kilobyte model was enough to understand the nuance of the CSI or channel state information that I needed to understand the spatial awareness of a room. Right. So I didn't need the model to understand everybody's room. I just needed the model to understand my room and then be small enough to be put on an MCU like ECP32. And that's 8 kilobytes. And if that was a GPU model, that would have been hundreds of megabytes or more. Gopher, how's it going?
Good. I want to share what I was able to do overnight work with automation. Can you see my screen?
Yeah.
I open source this skill. It's called Sheet Task. I love it because it take one thing. It can be a GitHub issue, a bead, or a document, and then it complete it. I feel that phase two here is the crucial part where it has um, scoring system of 4 different categories. So after completing the work, it goes through these 4 and it makes sure that it reach the score of 95. Otherwise, it go and fix it more, help a lot. And then phase 3 here would be it goes and fix documentation. So every session, I love opening new sessions every time. So this is using the Cloud P still. And within the session, there's so many learnings, even oops that Claude didn't notice before. So it go and update the documentation, and then it commits that. On top of that, I created a next skill that basically calling that sheep task and just know I need this into a PR and then merge the PR. So I always use a clean main. And then I made a script, a bash script, Claude did, right? That just now I can just ask it, go for it. And then it's running as long as it see tasks, it will bring the next one. And when there's no more task or a human is needed and it's stuck, and then the script will end. So I found this to be
Yeah, that
super
sounds
valuable and
awesome.
able to go run. And I really think that scoring plus update documentation was really helping. There's almost no drifting of like, whoops, something broke because before it happened all the time. So as I'm working on specific tasks and different things, it keep the whole system workable and not broken.
The other thing I would suggest, if you're going to include a script in your skills or your Codex or Claude plugin, make it an MJS or something that can run in both Windows, Mac, and Linux. The problem with SH files is you basically are shutting off the Windows world when you use them.
Mm.
And to be honest, the MJS format works just fine across all three, and you actually have all the benefits of a shell script but in Java
Yeah,
or JavaScript.
that's a cool idea. Yeah, but
Yes.
I'm fascinated with the ability to, because I did some experiment with Haiku. I'm like, do I need the Opus 4.7 Max? And Haiku was very happy doing tasks. A day later, I asked Opus like, okay, what about these PR that created by Haiku? And Opus was like, who wrote this nonsense, right? Like, so how do I know when using a lesser model that it knows that things are not correct? Because it is also trying to be achieving and make us happy. So haiku is like doing work, but not good work. So do you have a way
Oh
to
no,
measure?
Haiku works great. I just don't ask Haiku to. I don't ask Haiku for or Haiku for its opinion. I ask it to do the specifics of what it needs to do.
What's
When
the
when it
implementation?
Yeah, so for opinionation, I use the vector store. The vector is the point of truth of the system. And the haiku needs to do is basically ask the brain, what do I need to do? How do I need to do it? What's the problems that we ran into previously, and what's the best solution to that? All of that exists within the vector space. Once you call the vector space first, then you don't need to have a long reasoning system in place, which is Opus 4.6. You don't need a broadly trained system like Sonnet, because you don't need any of that stuff. All it needs to know is what is important based on the parameters of your environment that you're in. And that's all vector.
Do you use ever Opus 4.7 for the other tasks that you find it useful there?
Sometimes I use it for deep research. So, and if you look at my skills, I arbitrarily switch models depending on the skill. So the system's capable of adapting, and there's a cost optimization skill I have that's always trying to limit my token usage for, through various means, including don't give me a verbose output sort of stuff. And that extends my usage and lowers my cost. But as far as I can tell, if you're running 24/7, or not even 24/7, but let's say business hours, 20 days a month, the cost to run this not using Pro Max or whatever 200 plan is about $30,000. And I've had a couple clients that are forced to use kind of the hosted version of Bedrock on AWS, and the corresponding one for Anthropic on Google, and both are spending around $30,000, and they're just doing kind of like what we're doing on the company's dime, and it's crazy, $30,000. So that's $360,000 a year if they did for an entire year. It's nuts.
Wow.
It's almost like token burn is a bragging right.
Token maxing, is that what they call it?
Right.
Yeah, it's maybe we should brag about our token usage. But we did back in, was it last July when Cloudflow took off, and we burned $2 billion worth of
Yeah,
usage.
that's right. That was a very hot month.
Yeah, that was a very hot month. All right, so by the way, just that fix I made earlier is done. It took about 10 minutes. Here, let's see. You guys want to check what that finally looks like? All right, so the final fix, I pushed the branch. The regression was fixed. I had local validation. I do smoke tests for everything. The PR 77 green, so I can go take a look at that and what that looks like quickly. So again, it closed it. I was too quick. I can't see, but there is essentially 70 tests that ran. And we can probably see that in my workflow folder. Let's see that for a sec. In GitHub, I think it is, and in workflows. So these are all the workflows. There's 70 of them, but you can see here like this tests the various parts of the things. So my cost tracker smoke test. So this is basically checking that my cost optimizations are always in place. What really bugs me and others is when Rooflow kind of loses its cost optimizations, and suddenly they're spending more than they have to. So what this does is make sure that works. You can see that my federation test, this is basically making sure that the federation of different agentic environments will work. So whenever I do a PR, it goes through all these integration tests. And this would be the main one here. You can see like neuro trading tests. So and it includes every single regression that I've ever had. Right. And the idea here is, here's a major regression. For whatever reason, the system loves to use this BSQL library, which is garbage and doesn't work on Windows. And for longest time, I would get rid of it, and then like some random thing would come out, and I'd get it back again, and it was driving me nuts. This keeps that regression from happening. Here's a one that validates the marketplace. So if you're obviously I get a ton of installs, so I want to make sure that I don't accidentally break the marketplace. So this does that. Verifications. Here's the neural trader one. If anyone of you guys are doing trading, this is basically making sure that the neural trader is always working appropriately. And you can see that there's smoke tests for all these. And in any of my plugins, you'll see here, like let's go to the neural trader just as an example. It's a popular one. So
Are those workflows a new format, or is that something you made, or is that a Cloud Code thing?
These workflows are a combination of something I concocted using GitHub workflows. So it's the GitHub Actions, but it's a combination of stuff that's specifically tailored to my environment. But it's 50% GitHub Actions. And you see here I've got like here's some more smoke tests. every one of my systems involves smoke tests, right? So back to how do you use the dash P? The smoke tests are essentially using the dash P capability. So when I'm running these smoke tests, it basically is like, does the thing work as expected? That's what the smoke test is doing. And every single one of my plugins, whether it's the Git or sorry, the Claude or Codex plugin or the npm style plugins, which you'll see here in the Claude Flow folder, have various smoke tests associated with it. So, lots and lots and lots and lots of tests. In the case of Roof Flow, I think there's several thousand tests at this point. And there's a new one that I just created just now. So the problem I solved earlier, which was I guess it's closed now, it will now have a smoke test associated with it. There's another error I guess I should look at. I think that, let's just double check that this one's closed. Oops, I clicked the wrong button. So this guy found a bug. And to be honest, the more people find bugs, the better my software gets at this point. So there, you can see here the interconnected relationship components fixed. Now it's always important to provide proof. Like I didn't just fix it, and here's the regression guard. This base, see this script I was telling you about here? Scripts, smoke, Ruve LLM, WASM runs a CI on every PR that touches this particular tool. So going forward, forever and ever, I will always have a check against this type of regression. So hopefully I never see this problem again. So in the 2000 or in the 2000 plus issues I fixed, that forms a catalog of all the previous fixes, and that'll run alongside every future fix as well. So I'm not just fixing it and forgetting it. I'm adding these, and that's in scripts. Let's take a look at that quick. I'll show you what that looks like. Scripts. There are a lot of scripts in here at this point, I'm sure. So these are yeah. So you see the smokes. So here let's go to the memory no stray DB kind of thing. So this is basically running a complex series of actions on my system to make sure that that particular form of regression doesn't happen. So plugin registry signatures, whatever it happens to be, witness drift. And the last thing I do, I've got verification. The verification system basically is proof that everything works, at least the things that I fixed anyway works. And that provides a cryptographic verification that others can run in Linux, Windows, and so on, and validate that the capabilities of the system work as expected. And that negates this whole Roof's creating AI slop that doesn't work for anyone but him problem I keep getting tossed my way. I can just say, well, here's my cryptographic proof, and you can run it yourself. Take a hike. Internet, how's it going?
Hey, Roof, I don't want to interrupt the flow. I just want to pose a question whenever you have a moment. Lately, there have been a lot of reports of various attacks, and I listened, for example, to this Matt Berman guy who just scared me immensely. And although I work in isolated containers, still there's so many reports right now of these attacks primarily through open source software. And so I was just wondering whether you have any recommendations or any thoughts around that. Many of these are zero-day attacks or whatever. And so I get paralyzed because I'm not a developer. I am just very afraid to download stuff right now. So just wondering your opinion.
So I suffer from the supply chain hack and attack as well. Like it's crazy. So in full disclosure, my Cloudflare last week was exploited through an environmental variable that I had created 6 years ago. And it was in a worker I'd long since forgotten. And basically they were able to create workers that created Rolex websites to buy bullshit Rolex watches or something. Anyway, I had to fix that, but that there's a constant sort of approach that people want to hack me and gain access to my million plus downloads. So the way I'm getting around that is I'm using a supply chain hardening approach, which is this particular GitHub component. And what that allows me to do is, again, as I do any new PR, the system is always looking for potential secondary supply chain vectors of attack. And what that means is I as you know, a lot of what I've built is built on my own core. I'm unique in the sense that I've built an entire stack and I use very few external resources, which lowers the blast radius. But I still am dependent on some. So what the easiest way to exploit my system isn't to hack me, but to do kind of what I just described in that exploit from 6 years ago is to find some vulnerability in some adjacent system that either me or someone else I'm associated with, like a package, forgot about or doesn't update or whatever, and then that gets put into mine. So what happens here is this allows me to define allowed dependencies. So, if someone's going to sneak in an extra dependency in a PR, for example, which they're always trying to do. That's why I don't accept that many PRs because they're always putting in back doors. And so this is going to say these are the ones I'm allowed to use. These are various findings. So there's a whole system here that allows me to sort of describe and cryptographically verify every part of the ecosystem that I touch. Now, the biggest vulnerability in my ecosystem essentially is me, because 90% of my packages are built by me, which are basically root vector related packages. I build a multitude of them. But this is how I handle it. The long story short is skills, plugins like Flow are particularly susceptible to exploitation, right? If you're going on some random website, installing some marketplace skill or plugin, that's, you're potentially opening yourself up for exploitation. And that goes for the stuff I'm creating as well, by the way. I just have a lot of stars so people feel comfortable using it, I guess. But you gotta, if it's free, you gotta be careful.
Can you share what you shared with us? And the other thing is, I was thinking exactly the same as you were saying. So since you have a lot of dependencies or some other package, the moment I see there is a ton of dependencies, I trust you. But the dependencies that you rely on could be vulnerable, right? So like I find myself, resorting to something else that doesn't have that many dependencies lately because I'm just, afraid.
That's the right move. I think you should be. It's really hard. Like, and the challenge I have is I put myself out there. So I've got a massive collection of stuff and infrastructure and tools and examples and applications, which makes me an extreme target. So, and it never ends. It literally never ends for people trying to exploit, my various systems and infrastructure. Um, I don't know if I have a solution other than to try to just have a view of what's happening best I can. I don't know if that answers your question. Man, I don't know. Anyone else have any suggestions or anything in terms of how they handle these types of the
So
eh,
I think obviously run CD checks as part of your pipeline. That's a simple one for code you're using. And then I think having something, I forget who said it, he was at the offsite we did in Vermont, but he basically doesn't use any skill directly. He says, I like this skill. This is a good example. Please write a version for me that does this and be sure that it's secure. So he never like code is an example now, not a something you reuse. I think that's the motto, and I think Groove kind of does that automatically, right? He goes, "Oh, I like this, but I want to be sure it's written in Rust and it's secure and everything." So I think that's a kind of a new practice now because 0-day attacks are becoming more prevalent, and CVs won't protect you from that.
well, there's the remember the exploit, at least I mean when it comes to roof flow for a moment, the exploit is not in external access. It's generally someone's not going to remotely access root flow. Maybe they could, I guess, through federation, but generally speaking, it's the exploitation of the system through granted access. You're going and saying dangerously skip permissions, then you're doing slash whatever, neural trader, go trade me some stocks. The challenge at that point is, especially, let's use neural trader as an example. Yeah, if I was a bad actor, what I would do is I would secretly take your token for Alpaca or whatever, Vantage, Alpha Vantage or whatever you're using to trade your stocks, and I would save that somewhere that I could access later. And you would likely never even know it, right? Because it would be done in a way that masqueraded as something that was trivial and normal in the system, but the system would then freely give me your token. Now, obviously, I don't do that, but the question is, if I was a bad guy and I was doing that, how would you know that I was doing that in all that random beeping and bopping that's happening in Claude code? The answer is you probably wouldn't know it. Now, to get around that, because I'm much like you. I don't want to just use my own stuff, even though I do. I want to try other people's work. I want to see what other people are doing. So I've got my AI defense system that basically acts as a kind of intermediary obfuscation of any personal identifiable information, ENVs, tokens, and other things I just don't want leaving my environment. And the second part is, Claude has made it a lot more difficult recently with their .env improvements to even have Claude see your .envs without explicit permission, which helps solve some of those challenges. But there's not really necessarily an easy answer to any of this at this point, other than you need to trust your whatever tools you're using and the people behind them, or
It's
not.
worth pointing out to reduce any VS Code extensions that you're actually not using. Just get rid of them, because there was a massive breach at GitHub due to a poisoned VS Code extension. I put the link in the chat.
Yeah. The VS Code extensions are some of the worst. They don't check them. They don't do much with them. Those are most. We're not talking CLIs. We're talking like the ones that are like integrated, like root code or cursor style extensions. Now, there are solutions to all these problems, but GitHub doesn't seem to want to do them. Like we could cryptographically do a better job of cryptographically signing those we could use packaging formats like similar to what I'm doing with my RBF format that allow for a kind of, a binary obfuscation along with the cryptographic signing of the package. They've made it a little bit too permissive, but I get why they've made it permissive. They want lots of people creating extensions. But the side effect of making it easy for people to create extensions is it makes it easy for bad people to make extensions as well and take advantage of the people who say, "Oh, this is interesting." Boom, I own you.
I think the extension problem is kind of why I don't see much of our group use OpenClaw. Because like isn't like 20-30% of their skills or plugin system are poisoned?
Well, that's because those guys did exactly the opposite that I did. So when I first became popular for Claude Code, I debated how many of these PRs I was going to accept, and I got thousands and thousands of them. And after a while, the fact that there were two predominant problems I saw. The one was the vibe coder that submits a change that touched 7,000 files. Like, there's no way I'm going to accept a PR with 7,000 file changes. So it was crazy. And there were a lot of those, hundreds and hundreds of those types. The other were people that did nice looking PRs that looked like it solved a problem or added a feature, but sneakily added these back doors and things. And I found dozens of those. I never accepted any. And after a month or two of digging through all these backdoor, latent PR requests, I'm like, I just can't figure out what's good from what's bad. And I essentially stopped accepting PRs altogether.
Should there be a
I got a
skill
bunch
that
of
helps you do it?
What's that?
Should there be a skill that helps you figure out which one has hidden
No, the problem with the skills was they were the skills like missed a lot of that. It's like, hey, go find me an exploit, and either it found me things that weren't exploits, or it would miss the ones that were truly are. And these guys are clever in the way that they masquerade their backdoors through polymorphic techniques that look sort of like something they aren't. And I don't have time to go through those to do that. It was too much work. I think at some form of CI/CD with CVE, and I could probably dream up something. Um, I guess. What I really need is people I trust to go and look through it, I think.
I think it's
It's
just
all
a good general rule of thumb, don't trust other people's potential prompt injection unless you don't trust that person or company. Because that's literally how plugin work. They are prompt injection as mechanism.
It's a skill. That's the skill. The any of those
Yeah.
skills you're downloading are prompt injections, straight up. Um, what's crazy, back to Ofer's example, I'm sure Ofer's skill is going to do really well because right now skills just do really well. With the reason why I've been able to sort of, I don't know what the right word is, reinvigorate root flow was basically I created a new path that was essentially install this skill and you'll get all the sort of root flow capabilities without having to install root flow. Now, what's actually happening is I'm giving skills that then go install all the Rootflow CLIs and packages and things as part of those skills. So you're ultimately getting the same stuff. You're just getting it incrementally versus all at one sort of init install up front. But when you take a step back, that is 100% a prompt injection. I'm using skills to basically deliver you my various CLI components in the form of an MCP or CLIs that are just invoked as part of the description and guidance of those skills themselves, which is, I guess a prompt injection. Maybe I'm being too honest.
That was the initial vibe I got from NCP. I was just like, that protocol is weird, but then everybody adopted it.
I've got my moments. I love it. I hate it. I love it. I hate it. It depends. I like it more that they figured out the context issue. I like it more now that I can separate my MCP tools based on args, so you don't have to install 200 or 300 different MCP tools all at once. And ultimately, I use the same structure for the marketplace approach with those 32 plugins. You can selectively add whatever plugins you want. You don't have to install everything. So it's, the benefits in MCP, at least in my architecture, is you get native performance. So I can, using the WASM and NAPR specification, I can basically get Rust level performance on using Node. So that's amazing. So I love MCPs as an alternative to a CLI because it allows me to have an open connection. So one of the drawbacks with CLI is there's a connection penalty. So you have to make the request to the CLI. The CLI needs to execute that request, then it needs to respond. With an MCP, I can leave that for certain things. I can leave that connection open as either a studio connection, which is a verbose output from the command line, or I can create an SSE style connection that allows it to basically remain open after I've done the request. And if I need more information from it, I don't need to make the request again. It's kind of an instantaneous. And the last part, what I ended up doing is using that quick protocol from Google, the UDP, and then that avoids any handshake at all for any API requests. So it's essentially a real-time stream of data without any handshake latency. So
What's the new protocol from Google you said again?
it's a protocol I call Quick, QUIC. You'll see that I use it. I use it in my federation system. Essentially it's a form of UDP, so it's eventually consistent. That means even when you have droppage in connectivity. So let's say I've got clusters coming and going. It can reassociate itself without any additional handshake after the fact. So instant availability. So without latency, and that's important on a network level. Like when you use HTTP or HTTPS, there's 100 to 200 millisecond latency on every request you make to a website. Now, that doesn't sound like a lot unless you're doing a lot of things, and then that adds up quickly. The quick protocol is a secondary protocol that you can define outside of HTTPS that avoids any of that sort of handshake latency. And it's amazing for peer-to-peer systems, federation systems, secure communication patterns. Essentially, it's creating your own unique message bus that sits underneath the internet, kind of like darknet of sorts.
Yeah, and it's self-healing, right? So if it misses because it's UDP, it'll just catch up because it will recognize that a transaction was missing.
Yeah, I tell you guys a UDP joke, but you probably wouldn't get it.
Yeah.
All right. That'll be the geekiest joke you hear all day. All right. I'm almost out of time here. I'm anything else you guys want to cover or
Oh, you over
that
Dino now? Is Rooflow completely node?
no, it's it's mostly Rust. It's mostly Roof. To be honest, it's mostly Roof Vector for and packaged as an NPM. So I like TypeScript in particular for configuration and sort of abstract logic that sits independently of the core logic. So when you think about like if I'm going to do a vector system or self-learning or RabbitQ or whatever the latest greatest algorithm is, I'm putting that into Rust libraries. And those are tight, they're small, they're fast, and I compile them as WASM or NAPI R depending on on the performance I need to get. Then I package those up and publish those to NPMs. Then I import those NPMs as dependencies within things like Rootflow and Agentic Flow and other packages I have. Now, the benefit to that architecture is blast radius. So when you look under the covers of Roof Flow in particular, you'll see that in the v3 folder, there's a whole bunch of like @ClaudeFlow stuff. Each of those is a unique package. So hypothetically, if I have an exploit, that's the worst case scenario. Let's say I have a bug in one of those packages. The blast radius is limited just to that particular package. That means that I'm not going to crash my entire Roof Flow system. If I make an update to the memory system, it only really affects that memory system. So that gives me more nimble development, and I'm less likely to create a release that breaks for everyone. And I've been lucky. I haven't really had a release that's broken so badly no one's been able to use it for a while because of that.
So is TypeScript interacting with the Rust via WASM or is it via binary?
It's a little bit of both. So the WASM is a binary technically,
Yeah.
and yeah. So when you compile Rust, you can compile to unknown. Compiling to unknown is essentially the WASM, right? And then you can compile to environments. Now, for certain environments, like the core of RuVector, I've actually compiled that for Mac, Linux, and Windows. And then for Mac, I did a ARM-based and an Intel-based architecture. And Linux is a little bit more forgiving, but I think I only did Intel. No, I did ARM as well. Yeah. Anyway, that's all part of the CI/CD. So every time I do a new Groove vector release, it goes and recompiles everything as part of the build process. Then it publishes it to the npm libraries. That's all
So
automatic.
so those binaries are inside the NPM.
Yes, and I can actually find if you're curious, I can find you one right now. I've got tons of them. Let's see here what we can find. And again, root vector is kind of the core. Um, that's it all originates from there. All right, so this is my roof vector. So we can see here we got my various things. Let's find one that's here. Here's one. Here's my attention. Here's a unified WASM. So what this is an attention WASM. So this basically does bindings for different attention mechanisms, neural, DAG, graph, whatever, Mamba. And you can see here that I'm creating a package. Where's the folder here? So this is the WASM, and these are this will be compiled. Where's the actual? I don't think I have the WASM here. I think it's compiled on. But if we went here to the root vector, let's find the actual npm library for a moment. Here it is, root vector. This library is not. This is an old one, but if we go to npm and we go here, unified WASM. Yeah, this is one I don't use that much, but we can look at the code. And yeah, here it is. This is the WASM. So it's 347 kilobytes on this particular one. let's also look at root vector for a sec. I think I have I think I separate those. We'll go to code for a sec. Yeah, here it is, WASM. So this one included a decompiler and directly in the core.
Wait, so
Yeah.
that wasn't applies for all platforms?
Yes. That's the benefit of WASM is you don't have to compile it for any particular platform. So if you go to, let's say, Root Vector, Root LLM, which is one of my more popular projects, you can go to code here. And oh, this one I got bin. And so okay. Just yeah, I'm not using a WASM on this one. So this one is using most likely, let's look at the package. Yeah, this one's using secondary builds. So this
Sometimes
one's
the
using,
libraries you might use aren't available in WASM. So you
yeah,
have to,
this one's
that is
using
the
NAPI.
challenge.
Yeah. So this one's using a NAPI approach. So the NAPI approach is essentially me replacing the runtime of Node.js. So the initial runtime for Node.js uses Chromium V8 engine. It's great for general purpose stuff, but for the things that I'm doing, I don't necessarily want to use that. So what this allows me to do is replace it with a either C-based or Rust-based runtime that I built specifically for that tool. So I've got full control over all the parts of what it needs to do. Um, so that let's see some other ones here. It's another popular one. Yeah, so yeah, I'm just packaging up separate systems. So you can see here I'm building it. It references other. Here we go. This is what I wanted to show you guys. Okay, so these are the optional dependencies. So the optional dependencies, you can see that I've compiled this graph-based system and replaced the runtime specifically for Linux 64-bit, ARM, Darwin, ARM, and so on. And now if we go to this, to this library, we'll be able to see. Here we go. I don't even have a README for this one. It doesn't even matter. Um, and we can see the structure of how this comes together. And this is referencing the location of the node file. Yeah, so it's basically downloading it from, I think, my GitHub. Oops. Oh, yeah, here it is. This is it. So this binary, how big is that binary? Oops. It's 5 MB. So that binary is the entire runtime that I'm using to replace Chromium V8. And this specifically has been compiled for Linux 64-bit GNU. So you can tell Linux is popular. Which is interesting, also as a basis of comparison, if we look at, so this also kind of tells me what packages are more popular than others. So if we go back here for a sec and we look at package.json and we scroll down, and let's just look at a less popular one. This this would be Mac in Intel. No one's using Mac Intel these days, so this will give us an idea. The number should be lower. Yep, 2,000 downloads, because who the heck uses Mac Windows? Or sorry, Mac Intel. And so if my thesis is correct, this should be higher because everyone's using ARM. Yeah, it's higher. I don't know if is that helpful? Is there my rambling about crazy,
It is helpful as I'm thinking about how to integrate like Rust into some kind of using TypeScript as distribution and user interface as well.
Now,
Uh,
if you're looking for performance, Nappy RS is what you want. Yeah, and you could do that in C. Like I've got a project that I'm doing with another customer of mine that's in C, and so I'm using Nappy-C for them because they're having issues with Rust for whatever reason. It doesn't matter to me. But so NappyRS, this is the system. Now NappyRS is great for really really high performance stuff. Like if you want to get direct throughput on your networking or system related components, you're going to use NappyRS, and that's why I used it for the graph stuff because I needed additional sort of capability. WASM is going to give you lesser. It's going to be good. It's going to be better than native V8, but it's not going to be as good as NappyRS. And this is basically giving you an example. So the transformation. I don't know. Take this. It'll take a sec. But for AI related things, it's spectacular. I don't know why more people don't use it, but it's once you figure it out, it's amazing.
Well, I'll look into it. This seems interesting.
Yeah, and then again, there's what is it? Nappy slash C, I think it is. Yeah, this is Nappy C. Now, the benefit of Nappy C is you can basically take a bunch of the C and C++ stuff that exists, and there's a ton of it for AI, and you can basically import it and use it in your Node.js libraries. Because if you've ever used C++, it's a pain in the ass because it's not the most friendly language for interaction. This essentially, as it says here, the Nappy API decouples native add-ons from the underlying V8 JavaScript engine. Instead of calling V8's raw C++ APIs directly, developers use the Nappy API C-based functions. This ensures that plugins remain compatible across different Node.js releases, even different JavaScript versions. Long story short, it allows you to use essentially Node.js as a distribution model for complex things that would normally have had to been you go through a build process.
Does NappyRS have the same library support problems that WASM has, or will anything in Rust compile into Nappy?
No, you need, and it does have compilation issues. Specifically, you need to compile for something called no, I think it's S, it's S, no STD, is that, I think it's what it is. Running must impure without C standard is entirely plus. You must bypass all standard I/O memory functions, relying on OS independent. Yeah, so you have to make some alterations. So yeah, no, sorry, no STD lib. This is specifically what you need to do. And you can just look at my stuff as an example because I've got a bunch. I use this heavily. But once you modify it, you get zero dependencies. So that means you can install a desktop app using this in seconds, microseconds, without that whole rigmarole of installing and waiting for it to do its thing. It's pre-compiled. It just works. No, basically no installation required, other than the package being downloaded, I guess. But other than that, once it's downloaded, it just runs. My suggestion, unless you've got a real reason to do it, like this company that has 2 million lines of C++, I would avoid C++. It's difficult to work with. It's inefficient. Rust does it better for almost everything you'd ever want to do in C++. You can do Rust better, faster, and cheaper.
That is why I hand wrote a inference engine because I was like, I don't want to have a C++ runtime to be bundled into this Rust stuff.
Yeah, exactly. And it's exactly and you can take a look at mine. You can see how I did it, at least as a basis of like a comparison. But I think building your own inference engine is smart. It teaches you exactly the inner workings of these systems. And if anything, for me, I learned that I don't need a GPU to do most of the AI and inference things that I needed to do. I could do incrementally. I could do in a CPU. And if it wasn't for me attempting to basically reinvent the sort of Olama myself, I would have been stuck using the crappy Olama stuff that was not exactly optimal. Nothing against Olama.
Yeah, very slow though.
Yeah, it's slow. It's slow because it's not optimal. It's not optimized. Let's Olama code base. What's it built in anyway?
It's based on llama.c++.
Yeah. So remember all the things I told you about why C++ sucks? Yeah, so first of all, you have to compile it. I guess there's precompiled versions, but
Also,
it's
the
just
binary size is way bigger.
yeah, so I showed you my Rube LLM earlier, which was 5 MB. This one, I guess compressed is 1,000 MB gig. Windows is a gig. We got a rock. This is
Oh
the
no, that's
Chinese
the
chip.
app. That's the app though. You should go check llama.c++. That's the actual binary for inferencing.
Llama, yeah, Llama C++,
Yeah,
CPP, is that what it was?
yeah.
Oops. Where do I gotta find their code base. Here it is. All right. 11 minutes ago, they're actively building. Smaller, much smaller. Still not as small as Rust, but not bad. Yeah, there's a lot of bloat around Olama, for sure. If you're gonna do the most interesting thing here would be if there's there a Llama CPP Mappy C. That would be a good project. Here it is, Node Llama CPP. This is the way I would do this is what the way I would do it too. I haven't looked too closely at it, but this makes sense. See, now you can just install it that way. Let's take a look. Let's take a look at their package.
Ocean. So in this case, you will use the same principle to use yours that is in Rust from the node.
Yes, I'm thinking about similar approaches. Basically have to package it because you can't just point you to a Rust library.
Yeah. I mean, if you use Nappy, then you will be able to use your inference engine that is
Yeah,
supposed to be that is supposed to be 2 times faster than this one's, no?
yeah, yeah.
Yeah. So,
I will package that.
all right.
Yeah.
You see this? So just a couple. So to Antoinette's point earlier, you notice how many dependencies they have? And you remember when you looked at mine a few minutes ago, there was basically none. They were all mine. That this is all supply chain exposed. Every single one of these is potential vulnerability, right? And so when you go and look at, my let's go to roof let's go to root vector just since we're on that. And we look at my code and we look at my package. I've got some in there, but these are all mine, or these are my tags. So these are my dependencies. So chalk, that's common, it's fine. I get commander, beautified. So basically nothing. I've got 3 external dependencies. I could probably lose those. I probably don't need the beautifier. But you see how much smaller my supply chain is compared to this random project that's got dozens of other things that who knows what's in this stuff. Like, why do I need why do I need half this stuff? Right?
Why do you need a Vitesse UI for a llama.c++, which
But
is
I'm
pretty
saying
weird?
it's just there's a lot of crap. And then making it worse, they've got both they've got dev dependencies for builds, which why bother including that? And they've got dependencies, a secondary set of dependencies here. Now I get why they want these. Like this is the actual this is actually the runtime. So they're actually using NAPI as the same approach that I'm using. So we go here and we can take a look. When we go to dist. Oh no, is it bin? Yep. So this is their package. It's 800K. They've also included a bunch of crap they don't need. This isn't needed. To be honest, if you were going to hack these guys, hypothetically, not you should hack them, this is your point of entry. I wouldn't include these.
By the way,
Unencrypted.
thanks to Martin, I just uninstalled all the plugins that I had in VS Code that are not Microsoft or GitHub or Red Hat or Anthropic. Just killed all of them.
Yeah, actually, I need
Thank
to
you.
do the same, and I need to
Yeah.
go back and remove the thing that was automatically installing them on some of my dev containers.
But I assume everything that is Microsoft, Red Hat, GitHub, these things should be safe, right? Anthropic.
Well, bear in mind that the people who got hacked from this was GitHub themselves,
Oh,
right?
okay.
You
Yeah.
can't trust
So,
you can't trust it. Yeah.
Okay.
but what are you going to do? Like it's a compromise between the functionality you need, right, and who you can depend on. And we're moving to a world where there are much larger numbers of bad actors, and a supply chain that can hit you over time. So,
Well, the only answer for me, and this maybe I'm a lunatic vibe coder here. The only answer was I created my entire stack. It's 100% my own supply chain. Pretty much every part of my supply chain. I showed you a few chalk and a few other things, but I don't even need those things. So the parts of my supply chain that are meaningful are 100% created by me.
that's why we're in your tribe.
But that's the future.
Uh, I would like to add something here for Antonieta. The same way I'm learning from the best to try to build my stuff myself too, by using your tools, of course. But then I just did a few days ago, I picked a project that is kind of, I was using it before, it was Git Nexus. So it allows you to go deep into the code and have a map of the entire code. So my idea was to use that package. So I took all the features. I didn't use it by itself. I took all the features and it included in my own project. And now on top of that, what I do is it builds a sandbox with that project inside and then maps the repo that I want to get anything from, or packages, or anything that I want to put there. So I asked them, okay, using this tool, go and check this project. And then what it does is builds the sandbox, install it inside, and then start mapping everything. And then I put on top of it AQE from Dragon, and I put the packages for safety, security that Roof have available. So it will do a full check of the whole package or repo or whatever it is. So
Smart.
after it's completely passed the test, then I will pick up exactly what I need from it and not just import it. So what I'm trying to avoid is to what he's saying, but is you still have chances to import stuff that at the end of the day it will be a backdoor. But the chances are minimized every time you do something like this, no? So that was my approach because I was getting crazy. Like Roof is already there.
Yeah.
But if it works correctly for me, then there are many packages that I've been creating that I'm putting together in a project. Then I'm planning to open source it somehow. I will talk to Roof. He can check it out and teach me how to do it. But I will be happy to share with all of you. But that was my approach for this case. In this case, I was getting crazy about this?
We're building some tooling and approaches. This is Michael O'Boyle in the we have an open source initiative. So really sort of whatever that level of assurance is, um, to try and make sure that things that get submitted to the foundation, either because you want visibility or that you want help or you want an opinion or you know that the best practices that we find get applied to the intake that we receive. And I think even for us individually, as we try and build things, it's not necessarily that we even want those best practices applied because we want it to be accepted by other people. But for ourselves, how well am I doing? Where are the exposures? What can I minimize? Like maybe I can remove a layer of calling a tool if I can call the API that tooling was just making more syntactically easier to read. Right? So just everything you can strip out to why not?
That's fascinating. It's like, does that imply that the future repos are really just pseudocode?
Well, I
Because
think
who needs the actual code if everybody's going to
Skills,
respawn in
skills
their
are
own
They're
pseudocode.
environment?
prompts. Repos are prompts.
Yep.
Yeah. You
Yeah.
guys hit the nail on the head. The skills are pseudocode, right?
Yeah.
And
Yeah.
There's
Now-
also this notion, I
Gosh.
think, calling it like a Phoenix approach, where you literally you whatever piece of software you're about to use, you burn it back to a spec, take only the bits, the essence that you want, and recreate the bird in your vision, right? So maybe it's a generic toolkit, but you need five of the features. Those are the ones that get instantiated in this round.
Oh, but by the way, if anyone's interested, I'm gonna order some of these cheap rings, smart rings out of China. If anyone wants to help test, I'll share a link where you can go on like AliExpress and order a few. I was thinking fooling around with some of the bio stuff.
Biosensors on the
Yeah,
ring.
they're cheap, like $20 kind of thing.
We're getting to the tricorder. That's wonderful. Yeah.
They don't ship easily to the US. I'm still waiting for ESP32 for like more than a month now.
Oh yeah, Canada. I guess there's some sort of trade war going on, but I haven't had any trouble. I haven't had any trouble in Canada. Like, side effect of this trade war is what used to take months to get stuff from China now takes like 5 days. So I guess nothing's being shipped to the U.S., so it's quick to get it to Canada. There's a bunch of other places you can order these things from, like like Arduino style sites. There's Mouser. There's you just gotta find the American distributor.
Antonita, this is Chris. Just send me a note and I'll get you a couple of them.
Yeah, actually,
Okay,
Chris is the one
thanks,
who turned me on to the whole thing last night. So, well, you guys can be our guinea pigs. I mean, beta testers.
Yeah, and how do you undo the intake for the request? As David said,
We'll share it in one of our groups. It's just these are just this is most likely just review. A lot of the stuff that I'm doing is if you go to review, you'll see that I've included a cog. Here, let me share my screen quick. We've got open source ethos, so you can always probably figure it out and do it yourself. But in review, we've got a new package too. I stuck it on here on our repo. Where did I put it? Edge modules, I think I called it. Where the heck did I put it? Too much crap in here. Maybe I get rid of it. Oh, here, Edge module catalog, I think it is. Yeah, here it is. So these are basically what I call cogs. These allow you to do specific applications of the review system for particular verticals. Fall detection, dream. This is me tracking my daughter's dreaming habits last night. Don't tell her. Sleep apnea. Use at your own risk. I'm not a doctor. security related, network related, and I think Nick has actually been working on UIs for all this stuff as well. So you can basically use it as part of the review system.
Yeah, my favorite so far was the forklift UI because there's like a bunch of forklifts on different floors, like driving around and dropping
You,
stuff
you,
off and picking stuff up and stuff. It's pretty cool.
do you have any demos you want to show
Like,
us? I got
yeah, if you want to see it, I can bring one
I
up.
well yeah, I'm gonna put you on
Yeah,
the spot.
the
A
forklift
forklift.
is the forklift one is the most it was funny to see it, just like these little forklifts driving around. Like, let me just pick this up
The,
here.
my biggest issue with I've got a new update, a much higher fidelity update to the review sort of 3D image stuff, but I'm not allowed to distribute the skin. But if you guys want to go install it, you can take a look. It's looks a lot nicer.
So you got some forklifts driving around on these different floors.
Sweet.
At first, like Claude had them all like running into each other nonstop, and I'm like, okay, like they're not that bad, They're not gonna all run into each other at once. That's what it was doing. And then I kind of had to tell it like, yeah, it has to be realistic. Like you have to make them like pick stuff up and drop stuff off. So that's
This is
like the
awesome.
the live view of them. Yeah, it's pretty
But
cool.
it's pure simulation, no? At this point.
Yeah, yeah, but you
Unless
can
you guys
see.
have you guys, if you have access to a factory of any sort, let me know. I'm looking for some better real world implementations. You know, I was thinking going to Home Depot and see if I could stick it on one of their forklifts without them knowing.
That's a good choice.
Yeah.
So yeah, that's the forklift.
So cool. Ruva, I shared in the chat something called ChatGME.ai came out a few months ago, just to see how fast LLM can be. When we spoke about repo is a prompt, like you type the question, the huge answer is already there. And I think it's by implementing LLM maybe on hardware, but I think we will all have it soon at some point.
Yeah, like an accelerator.
Yeah.
There's there's certainly no shortage of opportunities these days. That is for sure. And all right, well, I'm gonna take a quick break before my next call. I've been blabbing here for a couple hours, so thanks everyone. You're more than welcome to stick around, but won't be
Super.
with me.
Your
Thanks.
roof flow, by
Thank
the
you,
way.
everyone.
All right. See, tomorrow we got AI Hackerspace. Same
Yes.
same time, different day.
Thank you, guys.
All right. Okay.
Bye.
Talk to you then.